The 0 volts, the LDR, the 10k and the 9 volt supply go together to make up a voltage divider. Okay, so the 9 volts is divided by the 10k and the LDR. So in the light, we've got a very small voltage here, that's about 0.3 volts. As we change the light level, the voltage coming out changes. So when it's dark, we've almost got 9 volts here, and when we've got light, it's nearly 0. Okay, so we're getting a big range of voltage out of the LDR. The LDR's resistance is big in the dark. Right? So it's a big resistance here, 1 mega ohm, and a smaller resistance up here. So this is taking a bigger proportion of the voltage. So the big resistance takes a big bit of the voltage. Okay, when it's smaller, it takes a smaller bit of the voltage. The same is true of the thermistor. Right, at the moment, it's 9.96 k. When I pull it down, so the bigger this resistance gets, the bigger the output voltage. Okay, so in the cold, V out is big, and in the dark, V out is big. The output driver we use in standard grade tech studies is the transistor. So we go in the light, the bulb is off. If we make it dark, you can see the bulb goes on. So we've got a current flowing in here of round about 0.7 milliamps, and the output here is 89 milliamps. So it's round about 100 times bigger. So the transistor is amplifying the current. The transistor is acting as a switch, and it's amplifying the current to be able to drive the output. Okay. We're now using a thermistor, so we can now get the circuit to switch on depending on the temperature. Okay. So in the cold, it switches on, and in the hot, it switches off. So at the moment, it's switching at around about 0 degrees. Okay. By putting a variable resistor up the top here, we can change the sensitivity of the circuit. So if I pull this down to about 100k, now instead of switching at 0, it's switching around about 30 degrees. Okay. There is a risk of using this variable resistor. If you accidentally take it down to 0, right, the current path comes down here, goes through the transistor, and there's too much current, and that will blow up the transistor. To get over that, we put in a base transistor here, that base resistor. That resistor there is to protect the base of the transistor from excessive currents. Now if I pull this down, right, the transistor doesn't blow, because that 1k is protecting the base from too much current. Okay, and it still works. The last component we need to look at with the transistors is the relay. This is a single pole double throw relay. There's a single pole, and here's the double throw. Now, there's a 9 volt supply on the control circuit, and there's an 18 volt supply on the relay. Now the relay could be switching 240 volts here. The relay lets you switch between a low voltage control circuit and a high voltage output circuit. That's its function. So let's see what happens when the temperature drops. Right, lights switch on, temperature goes up, the lights switch off. Now, when you're using a relay, when it switches, it has a coil in it which produces a magnetic field. And as it switches off, the magnetic field collapses and it makes an EMF. If we switch quickly, the transistor may blow up. Okay, so we've had a voltage of 124 generated by that relay, which has destroyed the transistor. To protect the transistor from back EMF, we use a diode. And the diode goes in across the relay with a wee arrow pointing up the way. Now we can switch away to our heart's content, and back EMF will not destroy the transistor. Right. So once again, the 1K protects the base of the transistor from excessive base currents. The diode protects the transistor from back EMF generated by the relay. The relay allows a low voltage control circuit to control a higher voltage output circuit. Okay? And the function of a transistor is to amplify the current and to act as a switch.